Hi, what's up guys? Welcome back to the lecture number 4. I am so glad that you guys stuck around with me till the lecture number 4, and in this we'll be talking about more Docker commands like Docker pull, Docker push and Docker login. These commands actually are the basics of Docker, which help us pull and push images from a Docker registry. Docker login, as the name suggests, is to log into that registry with your credentials, and just to enable that you guys also have to do some setup. That setup is just to log on to hub.docker.com and just create an account just like you do on every website, and come back to your command line and type docker login, and you'll be asked with your same credentials again. Just provide those credentials on your command line and you'll be done. If you get login succeeded on your command line, that means you're actually done. If something else happens, if some error pops up, try and find that online or reach out to me in the YouTube's comment section and I'll be happy to help you guys. So the agenda for today is that first we'll begin with the solution to the lecture 3 exercise. Then we'll try and pull and push images to Docker Hub. Then we'll be versioning the Docker images, since whenever we're working on Docker projects, we'll obviously have to version our software. So we'll also see how to version the softwares and how can others pull them by the version. We'll also be using some environment variables to make our setup configurable. So we'll also know some use cases of environment variables. We'll also use some build time variables using the arg command, which we have not seen yet, and these are quite important when you want to make different versions of your Docker images. So let's get started. So first we'll see the solution to lecture number 3. We had to use an external script in a Dockerfile. These were the things that you were asked to do. You have to expose multiple ports, and you also have to try and move these CMD block into an external script and invoke it. So I'm going to switch to my terminal now. So I'm going to actually create another file called solution.dockerfile, and in this let's copy the contents of our actual Docker file present in day 3. And I'm just going to copy a file called init.sh. You can name it anything you like, but this is the script that we are going to use and replace the below command. So the task was to replace this command with an internal script, and I'm creating this script in which I'll be using this command. So I'm just copying that script from my current directory into the root of Docker. Then I'm going to run a change mode operation on it so that it can be executable. Again, I have to use slash, not dot slash, because it exists inside Docker. And then I'm going to remove all this command here and use slash init.sh. So what I've done is that I've replaced that command, whatever was written here, and I'm going to use those command in the script file. So first the file will be copied to the root, then a change mode operation will be done, then these things will be done, and when you run Docker, when you run the container, only then the CMD will be invoked, and then this script will be invoked, which is placed inside Docker after the Docker build is done. So now, since we have created another Docker file, let's do a Docker build. Give it a tag. I'm going to give it day -3 solution, and since my Docker file is now of a different name, I have to use -f option. So whenever your Docker file starts with a capital D Docker file, I'm going to cancel it and show you guys so you can see it clearly. So when you name your file as Docker file like this, Docker can easily find it. But if it has some different name, you have to make Docker understand it, help Docker find it, So make sure that when you're building Docker, so you use a tag. I'm going to use day 3 solution, then use -f to point to that file, which is this. Again, the build context remains the same since it is dot, so I'm going to use that, and it has built it successfully. No, there's some error. It says that okay, we have not created that file so that it can be copied. So I'm going to create a file called init.sh. I'm going to move in that file, and I'm going to write the same command that we had written inside the Docker file in the cmd block, which was python -m http.server 9001. I'm also going to add an echo statement so that starting http server, right? So you see that when we use a shell file, it also gives us a way to add multiple commands, and it is quite clear and manageable to do this. So that is why people use a script file and invoke it from the cmd and not run the whole command from there, unless the command is short, obviously. So I'm going to use this, and I'm going to save my file, and I'm going to do a Docker build since it was failed earlier. So now it ran successfully. Now we are going to run the Docker. Make sure you port forward as well. 9001 day 3 solution. So let's see what happens. Oh, it says port is already allocated. I'm going to see if my container is already running or not. Yes, it is. So I'm going to do docker container kill, copy this container ID, and do this. Let's run that again, and this ran successfully. So now let's go back to our browser and see if this is running or not. Refresh the browser, and you see that a foo.txt that was copied. You see the new file, the init.sh, it is also copied as well. So let's go back to the terminal. I'm going to stop the Docker container. Wait, I'm doing a Control-C and the Docker container is not stopping anymore. What is the problem? There's something wrong here. Let's try and kill the Docker. So find out the container ID. Docker container kill. Yes, I have killed the container, but still that was not elegant, right? I'm pressing Control-C and somehow the Docker is not returning. So what happens in Linux is that whenever you press Control-C, the process that is running and the parent process that spawned that process has, when we do a Control-C, there's a signal that goes back to the root process, and it knows that now I have to terminate this process. Somehow that connection has been broken, and when we ran cmd, the control was with Docker because cmd is Docker command. But when we moved that thing, when we removed our command from the cmd to an external script, now the script has taken control. So now we need a way to tell the Docker that you need to send out the signal to terminate. In order to do that, Docker gives us an option of attaching a terminal, a pseudo terminal to it. So I means interactive and T means attaching that terminal to it, so that when you attach a terminal to it, it basically maintains that connection of sending out the signal. That when you do a Control-C, it sends out that signal of kill back to the parent process, so the process can be killed gracefully, which was not the case earlier. So I'm going to add -ti here and then run this. Still the things are same. I'm going to open the browser, refresh it, and things still remain the same. That means the service is running fine. And let's do a Control-C. Yep, So you see the output that keyboard interrupt received, which we did not get the last time. So that means now the interrupt was received, and that is why the exit was graceful. So this was quite critical. Most people actually skip this part and then they face issue when they try and run Docker images. So make sure when you run this, when you are using an external script, make sure you attach a sudo terminal and do a TI. And I would also like to point out one thing, that all the window users either use your command line, your CMD, or use what they call as power terminal, something like that. Use that. But if you're using git bash, make sure that you prepend winpty before all your Docker run commands, because winpty is actually a way to run that successfully. I don't know what that reason is. I'm forgetting that reason somehow, but all the window users should use winpty whenever using from git bash on your Windows system. Anyways, I'm on Linux, so I cannot reproduce that for you, but if you're using Windows, that was one invaluable information for you. So I'm back to the agenda for today. We have seen the solution. Now let's start looking at the pulling and pushing to Docker Hub. So let's say I want to pull an image, or I want to do a Docker run. So I'm going to first show you my repository on hub.docker.com. So that is how you will log into your Docker Hub, and you can actually create multiple repositories here onto which you'll push that you'll be pushing that. So let's create another repository. I'm going to call it day 4 YouTube, or let's call it just day 4 day 4 Docker tutorial YouTube. So I'm going to make it public so you guys can also pull and push from it. So I'm going to create it. So this is the way to push it, but I'm going to show you back in the terminal. But make sure you note this name. This is our repository, and this is our repository, and this is basically our account. So let's try and push to this repository, right? So we already have, and I'm just going to find out the first 3 Docker images. You can see all the images that you want, but I'm just going to use the first 3 so that the output is not large enough. So I'm going to use Docker 3 solution, and let's push this image. It says that it's around 217 MB. So the first step to push a Docker image is to tag it, give a tag to it, right? So and then this is the image that we built. So this was our source tag, but I want to give it a destination tag so that it can be identified by the repository name. So I'm going to give it my repository, my account on hub.docker.com. That's my username. / the repository name is day 4, and I'm going to give it version number 1. So that is how you version your Docker images. So when you do this, it will tag your image, and now you need to do a Docker push, and in order to push that you use this tag, because that is your target tag. So now Docker says that it refers to the repository on docker.io cafebabe. That's my account name, and this is basically the repository. So it is trying to push that based on your internet speed. This might take some time. Now that we have pushed the image, let's go to the browser and see. There's nothing here. I'm just going to refresh it now. Yes, so we have a v1 tag here. So it says that it was pushed about a minute ago, and it says the operating system is Linux. Let's see all of it. So we have one image here, and it's of compressed size 75.12 MB. So it also gave you a command, to Docker pull it. So let's go back and just do it. This is how you pull an image. So Docker pull is to pull an image, and then you give the URL for that image. URL usually starts with the repository name, with the basically the registry name. So registry in our case is docker.io. The project inside is cafebay1991, and inside that there's a repository, and then with colon you separate the version. So we had a v1 tag there, so I'm keeping it v1 here. So let's see if it is able to pull it or not. Since I have it on my local, it is going to say that image is already up to date, right? So in your case, you might have the same output as well, but you may try and use my image instead. You try and pull my image, so you will see that it will actually try and pull this image. Or to see that it is actually pulling from the internet, you can do this, docker pull, for example, hello world. This is the basic Docker image. If you guys don't have it on your system, maybe it'll try and pull it from the Docker repository as well. So you can try and use this instead, so that you actually see that it takes a little time, because this image is really small, so it will happen really quickly based on your internet speed. So you can try and do this instead of this. So that was Docker pull and Docker push, and we also saw how to tag our images. So if you want to create another modification in your Docker file, so you can do this. For example, we had to use multiple expose, right? So let's try and expose multiple. That was the second part of the exercise. So you can expose another port here, save it, and now you can do a Docker build again. Make sure that the file is custom, so we'll use the -f for it, day 3 solution, and I'm going to use -f since the file is different, and dot because we are on the current directory which we want to build. So this ran fine. You see that we had multiple expose here, and now when we run docker run -p 9000 to 9001, and we can also use the another port that we exposed. So for example 9001 on our host, or just for not causing the confusion, I'm going to use, for example, 77, right? And inside I wanted to use 9002, which was the another port that we exposed. But since there is no service running on that, we should not be seeing anything, right? But just to give you a clarity and to give you the solution for the last exercise, I'm using this, and the name was day 3 solution, right? So let's run this. So this ran fine. Let's see our Docker, what is the output of our Docker container ts. So now you see that if I just reduce the size of it, you see that the ports, there is one port which is redirecting from 9000 to 9001. There is one which is redirecting from 7777 to 9002. So let's go to our browser. So So 9000 should work as it is, but 9000, or sorry, the base was 7777. It says the site cannot be reached. Again, it says the socket cannot be connected. Obviously there is nothing running inside Docker on the port 9002 which we forwarded from 7777, right? So this is fine, this was open on the host, but there is nothing running on 9002 inside Docker. That is why we could not see anything on our host. So that is how you expose multiple ports. Now, okay, you see that fault. I have not used the -ti option again, so I'm going to kill the container, which is this docker container kill. So the container was killed, this was stopped. Now I could have, just do -ti. Make sure that you guys do as well. -ti is option. It's not, I wouldn't say it's optional, but for the graceful exit to happen when you do a Control-C on it, this should be there, right? So we modified a Dockerfile again. Let's create another version out of it. So the first step is to tag our image. So do a tag day 3 solution. So this is our source tag, and now we're going to give it the target tag. This should be the path to our Docker image on our registry. So I am not adding docker.io because this is automatically used by Docker based on your Docker login. So that is why docker.io was skipped. If you're using it internally, if you have your own registry, if you're working in a company, you might have your own Docker registry there. So instead of using docker.io here, you will be using that host name here, and then where I've written Cafe Bay 1911, this will be your project, something like foo project, and inside it there'll be a repository. In my case it is day 4, and I'm going to give you it another tag which is v2. So done that. Now we do a docker push on the target tag, which is v2 this time, and this says the push refers to the repository. This is your basically registry is a host name, this is the project, and this is the repository inside that project, right? And v2 was the new tag that we gave to it. If we go back to our browser and we refresh this page, we only had v1 earlier. Now we should see v2 as well. Great, we have v2 as well, and this is the Docker pull for v2. You can try and do that yourself as well. Let's go back to the agenda and see what all things are remaining now. Environment variables, just to make a configuration more maintainable. So let's go back to our terminal. Now let's try and use the environment variables to make our Dockerfile more configurable. So let's find out the problem with our Dockerfile first. You see that the port that I'm exposing here, this port is actually hard coded here. I want this port to be used or can be changed at runtime. So for that I'm going to use another Docker command, which is env, and I'm going to expose, say, HTTP port. That's the environment variable, and I'm going to give it a default value of 9001, and I'm going to use it here as well. So this is how we access the variable inside Docker. I've used $HTTP port, and since this is an environment variable, environment variables are usually set inside an OS in the Linux. So when this script is going to run, it will have the access to the environment, and obviously to the environment variables as well. So this environment variable HTTP port will be available to us and to this script inside the Docker. Since this script is running inside the Docker, this port can be easily accessed from the script. So let's go back to that script, and instead of hard coding this port here, I'm going to say HTTP underscore port, and for the sake of it I'm also going to print out all the environment variables. So here let's run the set command. I guess the set command will print all the available environment variables. So we'll also see that, and we are using the HTTP port here. So now our HTTP server, for some reason if the port is not available, we don't have to change our Dockerfile anymore. We can easily pass that variable HTTP port. Since it's an environment variable, we can just pass in the environment variable whenever we are running the Docker container. So I'm going to show you how. First, run it as it is. So I'm going to run the docker run command. How to use the environment variables. So open the Dockerfile, and you see that these ports are somehow hard-coded here, and whenever we have these ports conflicting on our host port, on our host operating system, we might get some errors when running a Docker. So the way around to this is to have these ports configurable from outside. So let's create an environment variable for it, because we can change them without changing the Docker file. So I'm going to call it HTTP port. The other port is just to show you the other port is not even used here, so I'm not going to use that. Or if you want to do that, maybe you can do HTTP port 1, and then you do HTTP port 2. So the port 1 will be 9000 and this will be 9001, and then instead of hard coding it here, we do HTTP port 1, and the other one should be HTTP port 2. So now these environment variables are exposed in our environment, so this script which is running inside that environment will be able to access it just like a normal environment variable. Even though these are given some default values, sometimes you may want to change this, since some other operation would be conflicting with it, so you might have to do something about it. So instead of changing the Dockerfile, you can now pass in your environment variables and change these at runtime. First, let's go to the script file. Yeah, I've already changed that before. I didn't show you, but I'm just using that HTTP port here, but the name was wrong, so I'm going to correct it. It's HTTP port 1 that we're using. That's the 9000. I'm not going to use the 9001. For some reason I could have used 9001 as well, but I have to choose any one of them, so I'm going to choose HTTP port 1, whichever that is. So let's save this file. Now build the Docker again, since we have changed something in it. So docker build -t, I'm going to give it day 4, and since it is present inside the current directory, I'm going to do this. You see that I have changed in this line. So that is why there's an update here. So I had to do some renaming here, that is why it is doing that. So now the image is successfully built. Now make sure that you use the correct way of using Docker run, which is using -ti, so that we can gracefully exit from it. And I'm going to change the port here to 9000, since I'm using 9000, right? by default value was 9000, so I'm going to use that. And this was day 4, the image that we built. You can see this, it was day 4, and the default value was 9000 and 9001. They were exposed by HTTP port 1, HTTP port 2, but right now I'm using it as it is, just to see if it runs or not. It is running, and this output was just to show you how this output is basically to show all the available environment variables with us. And you see we also have our own environment variables right here, and they have these values. So now, since the image is already running, I'm going to close this. Now say I want to change the port now. So in order to do that, you do -e. E is to expose an environment variable or pass a value for the environment variable. So I'm going to use HTTP port 1, because that is what we were using in our script file, and I'm going to give it a value of 8080. So make sure that you use the same value here. It is 8080. And now let's run it day 4. Now we can see that the HTTP port 1, the value was replaced, and we did not rebuild the Docker again. So that made us, that made our configuration, that made our Dockerfile quite configurable. And if you see this, now our HTTP service is also running on 8080, since we have used that in our script file, which is running this server. So that is how you configure it. And so go on to your browser and use 9000. Earlier we saw the environment variables. Now let's see the build time variables. So one thing to note is that the build time variables are different from the environment variables, since they can only work when you're running the docker build command, and the build variables are only available after the point you have declared them. And to declare them, you need to use the arg command, arg. I'm using that arg command, and I'm going to use, for example, call it base image, right? So I'm going to use the base image here, and let's replace this with base image. So now what we have done is that we allow the user to create multiple versions of the image. So instead of creating multiple Docker files with just the from command changing, I'm just going to parameterize it using the arg here, and let the user pass this base image while building it, and we can create multiple images for it, right? So just like we use the Python slim, in this we'll try and use another version of Python. So let's do a docker build -t day 4, and let's call it stretch. Stretch is another version of another tag given to Python docker image. So we'll try and use that, and just to use them you use build arg, and the name was base underscore image, and we're going to use Python stretch. I hope that is available, and use this. So you see that now another image was being pulled from the repository, right? And once this gets completed, I'm going to show you how to make another version of it without even copying the Docker file. So that is pretty cool. So for example, in a development environment you want multiple versions of Docker. So instead of copying that Docker file, changing the base image type, you can parameterize it using the arg command. So you can basically parameterize your base image using the arg command. So the download is happening. Let's wait for that to complete. So now we see that the new image has been built, but this image was using the stretch version of the Python. Now let's try and use a different version this time. Let's use the slim version again, which we do not need to download since we already have it. So let's try and use it here, Python slim. See, this time it is using everything from the local. It is not downloading anything because the slim version was already available to us and the stretch wasn't, so that is why all these pulling and stuff like installation of the software was done again. So that was using build time variables using the arg command. They are pretty cool, I think, because when you want to develop different versions of a Docker image, they come really handy. One difference between the environment and build time variable is that environment variables are present in the environment, so you can use them in the CMD or the script that you're invoking there, just like I've used that in the init.sh. But the build time variables, as the name suggests, they are only available during the build time, so you cannot use in the CMD block, since the CMD block is actually run when the Docker container is run, and build time variables are only available during the build time. So that is quite a critical definition and distinction between the two, so make sure you know that before you try and use that. So we have completed the agenda for today. I hope you guys learned a lot. Do subscribe to my channel for latest videos that I'll be uploading very soon. I'll be covering a lot of different topics about Docker and how to create applications with it. Those lectures are going to be really important, so make sure you subscribe my channel so you get all the notifications that you need. If you have some constructive feedback, if you like the video, share your likes. If you run into some problems, write me down in the YouTube's comment section. That's it from my side. Stay home, stay safe, and keep learning. Bye bye.